Okay, let's move on to the next question. So we have the ABC. Okay, now we do this one. It's a right triangle. We do the CC1, right? Okay, so this one you need to be very familiar, okay, in the future. So you can see if for the big triangle, this is the A, right? This is the angle A. So this is the angle 90 minus A. Then this is also a right triangle, right? 90 minus A. So this angle must be A, and this is 90 minus A. Okay, so let's see the C1, right? And this is the C2, right? So if let's find some patterns, okay? So let's check the C1 over C2 against the CC1, right? So let's find some pattern here, okay? You will find some pattern. So C1 over C2, right? So C1 is the leg opposite to the 90 minus A, right? CC1 is the hypotenuse. So what we see is this triangle. This triangle is similar to the CC1, C2 is similar to triangle the ABC. Okay, so if this is the case, now we know the C1 C2 over CC1 is equal to, right, 90 minus A. So here is the 90 minus A is corresponding to the AC over hypotenuse of the AB is 4 over 5. So you can see the C1 C2 is 4 over 5 of the CC1, and if you do the next one, you can see the C2 C3 equal 4 over 5 of C1 C2. Now we construct a geometry sequence, right? So it's let's see the C1 equals, what's a CC1? Yeah, CC1. Okay, let's see the CC1 equals A. Okay, then we have the A plus the 4 over 5A. Let me see. CC1, yes, CC1. 4 over 5A, 4 over 5 square A, plus so on and so forth, right? So if this is the case, so let's see, this sum is T, okay? Then what we can do is 4 over 5T is equal to the 4 over 5A plus 4 over 5 square A plus forever, right? Now we can see the 1 and 2. So the 1/5 of the T is equal to A. Now the T is equal to the 5A, right? So as long as we figure out what is the CC1, now we figure out everything, right? So it's not difficult. So because the CC1, this triangle, right? Let me use another color to write. Okay, so triangle CC1A is similar to triangle. We know the size of ABC, right? So we want to use the ABC. CC1A, right, is similar to the triangle the BCA. Okay, so that means you can see the CC1 is opposite to the angle A, right? is then over the BC is equal to, right, is equal to the hypotenuse of the AC over the hypotenuse of the AB. So we can see the CC1 is equal to BC is 3 times the AC is 4 and 5 is 12 over 5, right? Okay, so now you solve the A equals A, right? This is important. You need to apply here that equal to 5 times 12 over 5 equals to 12. Next. So this one let you to say, we cutting a big equilateral triangles by dividing their size into the four segment with equal length. That's this, right? And it consider all these points. So we cut it 1, 2, 3, 4, 4 sections, right? And if we do the n sections, it let you prove that all the odd numbers, continuous odd numbers add together is n squared. Okay, so let's see. Let's find some patterns. So here is a 1, right? Here is a 1 and a 3, right? So it's you see it's 1, 5, 7. So this is the continuous. The square, right? So this is equal to 1 square. This sum is equal to 2 square. Okay, so let's use the induction to prove. Okay, let's see 1, 3 up to the, this is the 2 times 1 minus 1, 2 times 2 minus 1, up to the 2 times n minus 1, right? Let's say we have the n layers first. Let's say we have the n minus 1 layer first. Okay, let's assume all this add up is n minus 1 square. Okay, this is the first step. The second step is we want to prove if we add another layer, right, is 2n minus 1. Let's prove it's n square. So we have the n minus 1 square for all the ones up. That's n minus 1 square, right? We need to plus the newly added, the last line is n minus 2n minus 1. Let's expanding this is n square minus 2n plus 1. Then we plus the 2n minus 1 is equal to n square. Done. Next. Yeah, this very simple. It's A, B, C, D. Okay, and they mentioned P is the midpoint. The AB is 6, so cutting into 3 and 3. The CD is 8, and B, C, and D is 2 and 2. Parallel, trapezoid. P is the midpoint, and the QR on the sides, and the PQ and PR are parallel to AD. Okay, PQ, PR. So this and this are parallel. This and this are parallel. Okay. So we have the parallelogram. We have the APQD, and the parallelogram of the RPBC, right? So you can see this is 3, this is a 3, and so this is the 8 CD, so this is the 2. Uh, what is asking you? Okay, we connected the BD. We connect the BD. We have the point crossing point of the X and Y. It asking you what is the PX against the YR. PX and YR. Okay. So first, okay. So we have the PQ equals AD equals 2. Okay. We have the PR equals from here. Okay. Equals the BC equals 2. So we know the QPR is the iso triangle, right? Okay. So let me color it. Okay, so these two sides are equal. So next step. You see the cutting point. All this cutting point, you need to use the parallel line, and you can figure out the ratio. Okay, so the first cutting point is x, right? How we use the px? The px is here, right? So did you see this? This is the px, right? And also the px, and also we can see this is another triangle, right? So we can see triangle pxb similar to triangle the qxd. That's why you can see the px over the over the qx, right, is equal to the pb over the dq is equal to 1. So the px equal qx. That means the px is a half of the pq. Okay, the second one similarly. Okay, you can see on the wire. Let me use another color. See about the y, right? And we need the yr. The yr is here. Okay, so we have another similar triangle. That's here. So the second similar triangle is triangle PYB, similar to triangle RYD, right? So we can see the PY over the YR is equal to the PB over the DR is equal to 3 over 5. So we know the PY is PY and YR is 3 over 5, right? So this piece is 3, this piece is 5. So we know the PY is 3 over 8 of the whole of the PR, right? And the PR and the PQ are equal, right? So that's why you can see the PX over YR. So from this one, we know YR is 5/8 of the PR, right? So PX over YR is equal to 1/2 over 5 over 8, right? And the PQ and the PR is the same, right? We already proved it. PQ and PR. Okay. So that's why this one is 10/8 is 4 over 5. Next, all these are very similar. It's all the cutting, okay? and you need to use the similar triangle. That's it. It's the A, B, C, D, and we have the AF, so this is the trisector point, F and G, and E is the midpoint, so E is the bisecting point. Okay, by symmetry, right? So it's let's see, if this is the A, then this is the A over 2, I mean 3A over 2 and 3A over 2. Then you have this one, intersect H, the H and J. So the area of the rectangle of ABCD is 70. So we know the ABCD is 70. So find the area of the AHF. Okay, so the AHF, to find the area of the AHF, right? We know the 3A times the B is equal to 70, right? The AHF is equal to half of the A times the height, right? Times the height, right? So we can, if we figure out this height against the B, then we figure out the ratio, right? So we can use the similar triangle because it's H, right? See this triangle and this triangle, they are similar, right? So the height of this, right, over the height of this, so you can see it's H1 over H2. So H1 over H2 also equals the AF over the CE is over E1 over 3, 2 is 2 over 3, right? So H1 over H2 is 2 over 3. So means this is the 2 piece, this is the 3 piece. So we can see the B is the whole piece, right? So that means the H1 is the 2 over 5 of the B. Now let's put this one inside H1. Let's put this one here. So 2 over 5 of the B equals to, this one now becomes the 1 over 5 of the AB. So now this one is 1 over 5 times 70 is 1 over 14. It's 14. Next. So given a acute triangle, okay, construct a straight edge. Let me see. Let's draw a acute triangle first, okay? Of the ABC. Okay, we want to have the DER on the BC, and we want to DEFG is a square, something like this. F is on AC. Okay, so how we can construct this square inside a triangle, right? Let's assume, okay, we already constructed. Let's see what's the property of this triangle, of this square we can have, okay? Now let's connect it to the BF. Okay, so how can we construct it? Let's see. Let's use the PQRS. Okay, so I mean, if this is the square, okay, if the DEFG is the square, right, and let's connect it to this, and let's do a parallel line of the PS to the DG and the parallel line SR to the GF, right? So based on the similar triangle, right, we have the based on our similar triangle, we know for example, this is the A, this is the B, right? So we know the QR over the EF from the triangle BQR, similar to triangle BEF. So we know the QR over the EF is equal to the BR over BF, right? And also we from the triangle I mean the BSR similar to triangle BGF, right? BSR BGF. Now we know the RS over GF is also equal to the BR over the BF. Did you see this? Okay, so this means if we can construct the QR, this means this, okay? If we can construct the QR and the RS, QR equal RS, then we can derive the EF equal GF. Okay, see, this gives us a way to do it. So we can pick any P to draw a perpendicular line. Then we make the QSR SR is equal to this. We can construct a square of the PQRS, right? We don't need to have to inscribe in this triangle yet. Now what we do is we connect the PR and extending to the F, right? Okay, now we can do, next is we can do the FG is parallel to the RS and the EF is parallel to this one. Now you can see if we have the FGE, right? Now we draw from the E, we draw another perpendicular line to this. Now we have the DEFG. Based on these similar things, the EF and the GF, right, is this ratio, is RS over this ratio is EF, and the QR over this ratio is alpha. So we have the QR over alpha is EF, and we have the RS over alpha is GF, right? Since we draw here is a rectangle, right? So that's why the QR is equal to the RS. That's why these two are equal. Okay, that's why you can use this way to construct a square. Okay. Final. Let's see. So the PQRS, so we have a triangle. Okay, then this is any point. Then we do the R. This one is parallel to this. TQ is parallel to AC, and the SP is parallel to this. What we want to prove is the PQ over BC plus the RS over CA plus the TU over AB is equal to 1. Okay, so PQ on BC is on this side, RS and AC on this side, and TU on AB on this side. So we have a ratio on 3 sides. So we need to use a similar triangle, try to converting it, okay? Let's use the BC as a reference. PQ and BC keep the same. Let's see the RS and the CA, okay? So this is the RS, and the CA is the big one, right? So did you see the triangle RSX is similar to triangle CAB, that means the RS over AC is also equal to the RX over the BC is also equal to the CQ over BC. Because they are parallel. This is the parallelogram. Now you can see we converting the RS over AC, we converting to a ratio on the BC. Okay, similarly, for the TU, right? So the TUX triangle is similar to the triangle of the ABC, right? So now you can see the second ratio is the TU over AB is also equal to the XU over the BC is equal to BP over BC. So now you can see we're converting the second ratio also to BC, right? Now let's write down CQ over BC plus the BP over BC. So PQ, BP, and the CQ together is BC. So BC over BC is 1. Done. Yeah, that's it for this chapters. Thanks a lot. Bye.